In this video, part 2, we will construct an object model which is a virtual representation of the physical test stand. This object model is used to easily control and query the physical test stand. In the next video, part 3, we will then manipulate the object model within a macro in order to create test sequences as discussed in part 1. So the object model is going to be comprised of this set of components: instruments, actuators, switches, and PIDs. So the first thing we're going to do is create a new project. We're going to open up Hiatronics Development Suite.
Welcome.
Go into File, New Project, and we're going to create a new project folder. Called Breathing Regulator. Click Open and then Save.
Welcome.
So now we have a new project. Next, we're going to go into the Tree View.
Tree View.
And we are going to add an application called Breathing Regulator. So add Breathing Regulator. Next, we're going to select Breathing Regulator. And we have our first application. If you go to the front page,
Welcome.
You can see that we have a breathing regulator, and we can add additional applications. This is called the front page.
The breathing regulator.
Front page. So we're going to go back into our tree view, and we're going to add a data acquisition board. Add, and we'll call it board 1. So data acquisition board 1 has been added, and there's digital, analog output, and analog input channels associated with the board. So we're going to click on the board and open up its property pages. Next, we're going to select a manufacturer, National Instruments, and we're going to select a part number. And the part number that we're going to use today is 6229. And it's going to ask you if you want to switch boards. Yes. And you can see it's red because the software automatically will detect any board that's plugged in. Right now, no board is plugged in, so, and then it'll turn green, and then it'll also provide the board serial number. Now, as you can see, the digital channels, analog output, and analog input channels have automatically been added. Next, we're going to add instruments. If you recall from the pneumatic diagram, we have instrument 1, 0 to 120 psig, instrument 2, which is 0 to 5 inches of water, and then instrument 3, which is 0 to 100 lpm, liters per minute. So we're going to add 3 instruments to our application, and we're just going to call it instrument 1, instrument 2, and instrument 3. And as you can see, they're automatically added to our interface instrument 1, instrument 2, and instrument 3. We're going to have to modify its properties in order to change its scale and wire it to a particular channel within the data acquisition board. So that's what we're going to do next. First thing we're going to do is put a label for instrument 1. If you recall, it was inlet pressure. So now inlet pressure is shown for gauge 1. We're going to wire it to data acquisition board 1, which we just added, and channel 0. And the units were PSIG. The scale is 0 to 120 PSIG. So range min is 0 and range max is 120, and that's all there is to it. You'll notice that the units out right now are in red, and that's because we have to add a calibration object. The channel is properly wired and it's green. So we're going to add a calibration object. We're going to call it calibration 1. And for now, we'll just leave it as a polynomial fit. But you can add it either as a calibration type 1 or calibration type 0, which would be a table value, in which you would put voltage and engineering units. But we'll change that back to that just to make it simple for this application. So polynomial constant 2 would mean that whatever the input is also on the output, so there really is no calibration. And if you go back here, you can see everything is in green. And as you can see here, PSIG 0 to 120, and then inlet pressure. So we're gonna do that for instrument 2 as well. Instrument 2 is outlet pressure, 0 to 5 inches of water. Wire it to a board, wire it to channel 1, and inches of water, and the range max is going to be 5. And again, we're going to have to add a calibration object. Go back here, double check everything is in green. Instrument 3 is going to be flow meter, outlet flow, 0 to 100 LPM.